Okay, continuing from part 1, 1-6, let me cover composition of functions. So this is a notation of composition. It's a dot, but it's empty dot. So be careful. Solid dot previously was multiplying. So f of g of x, that's empty dot, is composite function. That notation is exactly the same as f of g of x. I prefer this notation better than this because it's clear for me what function is inside, what function is outside. The g of x is input of f. G of x as a whole function goes inside function f. That's what I mean by composite function. The domain of f of g includes all x values in the domain of g that maps g of x values in the domain of g as shown. So f of g of x, after you make a composite function, how do you find the domain of that? Make sure x satisfies domain of g of x. But among those x value, g of x should satisfy domain of f. So you have to consider two tiers. X should satisfy domain of G, but not all those X you can take. Out of all those X's, you have to consider G of X should satisfy domain of F. Okay, so I will probably explain that to you over examples. Okay, example 2. Given f of x, g of x, find f of g of x. So notation-wise, f of g of x, first I need you to understand this is a composite function, okay, empty dot. I need you to understand this is exactly the same writing as this, f of g of x, g is inside, which is exactly the same writing as this, f of g of x is x plus 3, okay? So here is my recommendation. When you deal with this kind of composite function, f of g of x, I need you to recognize that as this is same as f of g of x. Once you recognize, g goes inside as an input, f is a structure, then this is how I want to set up. F is outside the structure, start writing f down. Except x. Okay, I'm writing f down to x squared. Do not write x. Instead, throw parentheses. Square minus 1. Structure like that first. Then you're inputting g of x inside. G of x, you plug it in inside the parentheses. Okay? Then all you have to do is just make it pretty. Parentheses square means you're gonna multiply twice. FOIL. So make sure you keep 2 for now, and parentheses, x times x, x squared. X times 3 plus 3x. 3 times x plus 3x. 3 times 3 plus 9. And close the parentheses. And combine like term here, 2 times x squared plus 6x plus 9 minus 1. Then time to distribute 2. 2x squared, 12x, 18 minus 1. Combine like term here. All done. Okay. Next question is very similar, but they switched around. They said find g of f of x. So I want you to understand this is exactly same writing as g of f of x. I like this notation better because it's clear what goes in, who is outside. G is outside. What does that mean? G is a function structure outside. Copy down G as it is, except instead of 3, you're writing parentheses. And inside the parentheses, you're going to plug it in f, which is this, 2x squared minus 1. Okay, in front of a parenthesis, there's nothing there, which means 1. So distributing 1 doesn't change anything. Just get rid of a parenthesis. Combine like term here. That would be it. That was a lot easier because you didn't have the distribution there. Okay, so following question is asking, get the f of g of 2. Function of f of g of 2. Well, we already did f of g of 2, not this one. This is g of f of x. The previous one, if you look at it, that was f of g of x, right? So since we already did the work, so I'm going to just look at the previous work here. F of g of x was 2x squared plus 12x plus 17. We already worked on this question. So I get to use that f of g of 2, f of g of x. All I have to do is just plug it in 2 there. Okay? So that's bracket, that doesn't matter. F of g of 2, I get to use this function because I already did all that work. Just plug it in 2, and that's it. That's what? 8, 24 plus 17. That's what? 49. Done. Side note. What if I ask you this question without asking previous question? What if I didn't have that ready? I didn't have that ready. So if I ask you this, but can I still go through f of g, previous step, can I do all that, get that, then plug it into? Yes, you can. But if my question is only getting this, there's an easier way to deal with it. Here is way you can do. So that's the same as f of g of 2. So my point is, you can calculate g of 2 first. What does that mean? 2, plug it in 2 for x, for g. 2 plus 3 is what? 5. 5 is the answer. Now you feed 5 to f. 5, plug in 5. 5 squared equal to what? 25 times 2 is a 50 minus 1 is a 49. So you got the answer of 49. Okay. Well, this one was available, so I just plugged it in there. But if I didn't have that, here's your one way you can get the answer faster. Pause the video, please. Please try this. You got this, you're good. Here I already did the work, so you can kind of compare your work. And if you made a mistake, make sure compare it and see where you made the mistake. If you have a further question, you should ask me during class or just join me for office hour. Find the composite function. Okay, find f of g and its domain. Okay, what did I say? F of g is exactly the same as f of g of x. That's the same thing. So g is a structure. So write down f. F is what? Square root of something minus 1. That's f. You're plugging in what? G. You plug it in inside here. You got to plug it in g inside here. X minus 1 parentheses square. So x minus 1, you're going to square it. You distribute this the x times x, x squared, x times minus 1 times x, minus 1, minus 1, okay? Plus 1, minus 1, they're gonna disappear. So it becomes x squared minus 2x. Find this composite function, I found it. Then you have to find the domain. Again, do you see the domain is coming back to this chapter? So that's style number, the number doesn't matter. Style number 2, square root with the domain. What do I do? You can try to find the domain of the square root. So inside the root domain, inside the root has to be greater than or equal to 0. That's how you set up the domain. Okay? So my preference is graphing. So I'm going to show you both. What I like to do here, I factor it. I factor x out, x minus 2 greater than or equal to 0. Okay? I factor x out from x squared. I factor x out from minus 2x. Because I know x is a common factor. In case you're not following what I mean by factoring, x squared divided by x squared divided by x. You end up with x. That's why you have x here. Minus 2x. Factoring x out means divided by x, cancel things out. That's why you have minus 2. So when you distribute, you get this. When you distribute, you get this. Okay? My preference, get the zeros. X equal to 0, x minus 2 equal to 0, x equal to 2. So I got 2 zeros here. 0 and 2. What do you do? Look at the coefficient of x squared, positive. What does that mean? It's gonna graph open up. Positive means open up. Negative leading coefficient means it's gonna be upside down, up and down. And what are we looking for? Y value greater than or equal to 0. Y value greater than or equal to 0 means above x-axis. So I'm looking at here and here. That's the portion I need. All you have to do is just express that in the interval notation. So where in x-axis is graph above x-axis? So here to here, minus infinity to 0, union with 2 to infinity. That's your domain. Okay, that's what I prefer. I know some of you don't like this method, then you can always do checking with this. So right here, you can do 0 and 2. You can just draw the number line 0 and 2. Then you have a 1, 2, 3 different intervals, and you're checking against this inequality. So you can pick a sample number here as like minus 1, plug it in minus 1 for x. Minus 1 times minus 1 minus 2 greater than or equal to 0, you're checking it. Minus 1 times minus 3, that's a 3, greater than or equal to 0? Yes, it does satisfy. So you are taking this portion, equal sign, you have to do solid dot. You pick a sample number here, we such as 1, plug it in 1 for x, 1, and check it, is that greater than or equal to 0? 1 times minus 1, minus 1, greater than or equal to 0? No, you're not taking that. Check a sample number here, such as 3, 4, 5, anything. So 3. I'll plug in 3 for here. 3 times 3 minus 2. Questioning, is that greater than or equal to 0? 3 times 1, which is 3, greater than or equal to 0? Yes. It does satisfy. So you're taking this portion, and there's equal sign, meaning you have to include it true. So from here, you just answer those. Okay, minus infinity to 0, bracket, union with 2 through infinity. Okay, 2 through forever. So I know some of you like this method better. I prefer this method better. Domain, you have to do either one and get the answer. Okay, you should pause the video and you should try this. F of G is the same as F of G of X. So F is a structure, F is this. So you should write that, set that up as like this. F is a structure, write down F as it is. Instead of X, you throw a parenthesis. And G goes inside, so G is inside. There's nothing in front of parenthesis, so that's it. We're done. That is the composite function. So from this, we have to find the domain. So this is a domain question, which is a little tricky because we have a root. Okay, we have a root. Also, this is a rational function. X is on the denominator, so it has a both. So do you remember, if it's a root, inside the root has to be greater than or equal to 0. Inside the root has to be greater than or equal to 0. But also that's a rational function, it's on denominator. Do you remember the other condition? Denominator cannot equal to 0. So denominator, which is square root of x squared minus 1, cannot equal to 0. Get rid of square root. Square both sides. X squared minus 1 cannot equal to 0. So right here, you have to satisfy this. You have to satisfy this. So cannot equal to 0. So you have to take the equal sign off. So x squared minus 1 can be only greater than 0. Then you have to solve for x. Okay? So x squared minus 1 greater than 0. So I'm using the same formula, x squared minus 1 squared, because 1 squared equal to 1. So this is exactly the same style as the very first question we did in front of this very beginning of this chapter. So you can do x plus 1, x minus 1 as a factoring. So I just used a squared minus b squared equal to a plus b, a minus b formula. Then you got the x plus 1 equal to 0, x minus 1 equal to 0. So you got minus 1 here, positive 1 here. So here you got minus 1 and 1. And if you look at coefficient, that's positive. So you got graph like this. What am I looking for? Y value greater than 0. That means above x-axis. So I need this portion. So I can answer from minus infinity to minus 1. No equal sign, so it's a empty dot here, empty dot, union with 1, comma infinity. That will be my domain. Okay? Again, guys, this one you can do a number line, put the 0, put the 0 here, put the 0 here, minus 1 and 1. You pick a sample number, plug it in. You can do that as well. Okay, I already showed you twice today. So I'm going to just keep with this example. Okay, one minor thing. I perfectly take this as a full credit answer. Your Alex might ask you to do rationalize the denominator. Okay, so if it's a paper-based test, this is a fantastic answer. Your Alex might ask you rationalize denominator, then you might have to take an extra step, which is something like this. So rationalizing denominator means they don't allow square root on denominator, period. So what you have to do is you actually have to multiply by square root of x squared minus 1, square root of x squared minus 1, a numerator denominator. So square root, that disappears. X squared minus 1 on the bottom, 1 times this root is just root. So for Alex, you might have to do this as a final answer. And if you sketch using graphing calculator, that's that. Okay, pause the video, please, then try it. So they are asking f of g of x, which is the same as f of g of x. G is inside. F is what? 3 over something. And g goes inside. X squared minus 1. So nothing to do here because in front of a parenthesis, there's nothing. So this is the answer. And and the domain. So we are supposed to say find the domain as well. Domain. This is our first style. We have rational function. Denominator cannot equal to 0. So you say denominator, trying to find the domain, cannot equal to 0. So x squared plus 1 both sides. X squared cannot equal to 1. How do you get rid of square? Square root both sides. When you take a square root both sides, please don't forget putting plus minus. That's how I lose number of my students. So square root disappears. X cannot equal to square root 1 is 1. Again, this is a fantastic answer as a domain, but for Alex, you will have to answer as a interval notation. So -1 empty, 1 empty. Everything else is filled up, so you have you can cover everything on the left, you can cover between, you can cover to the right of +1. So we have 3 intervals to express. First interval, left to right. So -infinity to -1. Okay. Second interval, -1 through 1, -1 through 1, union. The third interval, 1 through forever. So 1, infinity. So that will be the answer for domain in interval notation.